Good evening, everybody. We'll be starting in a couple of minutes. Let's wait for everybody to join in. We'll wait for 5 more minutes and see if people join in. We'll wait for 5 more minutes before we begin. Okay, welcome to the 12th week and the final week of this course, Genome Editing and Engineering. This week deals with the ethical considerations in genome editing. So just so if you so you know, I am Sanket Mukherjee, a Prime Minister's Research Fellow from School of Biological Sciences, IIT Delhi, and this is the course Genome Editing and Engineering. taken by Professor Utpal Bora from IIT Guwahati, Assam. So going to the first question right away. The term bioethics was coined by Fritz Jar, a Protestant pastor, philosopher, and educator in Halle in der Saale in the year 1629, 1926, 1962, or 1992. I'll give you a couple of minutes to think on this and then we will discuss the answer. Okay, so the answer to this question would be the term bioethics was coined by Fitzgerald, a Protestant pastor, philosopher, and educator in Yale and De Sale in the year 1926. So let's have a look at some of the origins of bioethics. So the very first origin, the name was coined by Fitzgerald, a Protestant pastor, philosopher, and educator in Hale and the Sale in 1926. Fitzgerald published an article entitled Bioethics, a review of the ethical relationships of humans to animals and plants, and proposed a bioethical imperative in 1927, extending Kant's moral imperative to all forms of life. He evaluated contemporary physiological knowledge and ethical issues surrounding the emergence of pluralistic secular society. In the process, Fritz reinterpreted moral obligations towards both humans and non-human life forms by defining bioethics as an academic field, a guiding principle, and a virtue. Regarding some of the historical developments with respect to India, India has been blessed with a magnificent code of medical ethics, code of medical conduct, right from 600 BC, during the time of Charak and Sushruta. The standards for a good instructor and someone who should pursue medicine are embodied in the Ayurvedic code. Additionally, it provides advice on how to interact with patients and their family members, as well as it provides helpful hints to utilize when addressing topics like organ transplantation and brain death. So Maharishi Charak was famously known as the father of medicine and surgery in Ayurveda. So he had developed these codes. Now, regarding what happened in the contemporary world, heinous crimes took place during the World War II on captives held in military concentration camps. During this time, defenseless individuals were forcibly subject to medical studies with questionable scientific merit. This was very much prevalent in Germany and many other nations during that time. So when the World War II it ended in 1945, the victorious Allied powers enacted the International Military Tribunal on November 19th, 1945. The first trial conducted under Nuremberg military tribunals in 1947 became known as the Doctors' Trial, in which physicians from the German Nazi Party were tried and punished for crimes against humanity for the atrocious experiments they carried out on unwilling prisoners of war. So there is currently Geneva Convention, which gives human rights to prisoners who are prisoner of wars, as well as the ones who have committed any crime. So the verdict also resulted in the creation of Nuremberg Code, a set of 10 ethical principles for human experimentation. The code aimed to protect human subjects from enduring the kind of cruelty and exploitation the prisoners endured at the concentration camps. Regarding bioethics, a very famous name comes up, Van Rensselaer Potter. So Van Rensselaer Potter was an American scientist who introduced the idea of bioethics as the global ethics in his 1971 book, Bioethics: A Bridge to the Future. With his extensive and lengthy experience in cancer research, Potter presented a novel interdisciplinary idea with the aim of fusing ethics and science. He intended to create a conversation between the science of life, that is the bios, and the usable knowledge, that is philosophy, ethics, and values. And as a result, the term bioethics was coined. Potter's bioethics united humility, responsibility, and multidisciplinary and intercultural competency. Okay, coming to question number 2, the Asilomar Conference was a milestone for science because it was the result of dash proposed by the scientists themselves. Is it bioethics, biosafety, self-regulation, or ethics? So I'll give you a couple of minutes to think on this, and then we will be discussing the answer. Okay, the answer to this question would be the Asilomar Conference was a milestone for science because it was the result of self-regulation, option number C, proposed by the scientists themselves. So let's look at the Asilomar regarding the Asilomar Conference on recombinant DNA. It was the beginning of bioethics in biotechnology. In 1975, 140 scientists, doctors, and legislators gathered in the Asilomar Conference Center in the State Beach, California, in order to debate the ethical implications of genetic engineering. Certain principles of biosafety were established at this conference with the object of preventing an accidental leakage of recombinant organism which could affect human beings, animals, or the environment. The Asilomar Conference was a milestone for science because it was the result of self-regulation proposed by the scientists themselves. At this conference, the scientists agreed that research with recombinant DNA should proceed, but appropriate safeguards should be outlined. Question 3. In case of heritable genome editing, there are two distinct concerns. Select the right options. The possibility of off-target effects of the editing process, as in the case of somatic genome editing. The intended genome edits themselves might have unintended consequences, even in the absence of off-target effects. Some worry that taken to its extreme, germline editing would create classes of individuals defined by the equality of engineered genomes. So is it option A, 1 and 2, option B, 1 and 3, option C, 2 and 3, or option D, none of the above? I'll give you a couple of minutes to think on this and then we'll discuss the answer. Okay, so in the case of heritable genome editing or germline genome editing, there are two distinct concerns, out of which the possibility of off-target effects of the editing process, as in the case of somatic genome editing, that is true. The intended genome edits themselves might have unintended consequences, even in the absence of off-target effects. Um, well, that is also true. Some worry that taken to its extreme, germline editing could create classes of individuals defined by equality of their engineered genomes. Well, that is, although that is a concern, but is not that much well as accepted as of now. So option A will be the answer. Let's go to the ethical concerns in human gene editing. So the human germline is the focus of majority of ethical debates surrounding genome editing, since any modifications performed there would be handed down to subsequent generations. Although the discussion of genome editing is not new, it has recently attracted attention because of the finding that CRISPR may make it easier and more accurate than previous methods. However, studies that would make the gene therapy safe and successful should continue, according to bioethicists and experts. Human genome editing for reproductive purposes should not currently be undertaken. The majority of stakeholders concur that ongoing public discussion and debate are essential to letting the public determine whether or not germline modification should be permitted. Due to ethical and security concerns, around 40 countries, including 15 in Western Europe, prohibited or outlawed research on germline editing as of 2014. So let's look at the ethical considerations. The first being safety. So the safety is the main priority when due to the potential for off-target consequences, that is the edits in the wrong spot, and mosaicism, where some carry cells, they carry the edit, while the others, they do not. Germline genome editing should not be used for clinical reproductive processes or purpose until it is until research establish until it is research established as risk-free throughout. So majority of researchers and ethicists is of the opinion that any risk cannot be justified by the potential benefit. According to some experts, genome editing in embryos will not provide advantages over already available treatments like in vitro fertilization and pre-implantation genetic diagnosis, PGDs. Regarding continuation of this safety point, even for therapeutic purposes, some scientists and bioethicists worry that any genome editing will put us on a slippery slope towards using it for questionable non-therapeutic and objectives of enhancing, which should not be the case. Others opine that once genome editing has been proven safe and effective, it should be permitted to treat hereditary disorders, and indeed that it is a moral imperative. Whatever the case, policy and regulation should be, whatever the case, policy and regulation should be used to address issues regarding augmentation. Last but not least, some who have commented on the subject are afraid that the regulation of genome editing for reproduction would differ between various countries, leading to chaos and issues of universal acceptability. So the second thing is informed consent. People are concerned that because the patients of germline therapy are embryo and future generation, it is hard to gain an informed permission from the intended recipient. The argument against it is that parents already make a lot of choices that will impact their future offspring, even if they are equally difficult like IVF. As long as the dangers of germline therapy are unknown, scientists and bioethicists are concerned about the likelihood of obtaining properly informed permission from prospective parents. Now comes the point of justice and equity. As with many new technologies, there is a concern that genome editing will only be accessible to the wealthy and will increase existing disparities to access healthcare and other interventions. Some worry that, taken to its extreme, germline editing would create classes of individuals which are defined by their quality of engineered genome. Now, what are the potential risks? Balanced against the possible benefits of heritable genome editing are a variety of potential risks, which include unintended consequences. So in the case of heritable genome editing, there are two distinct concerns. The possibility of off-target effects in the editing process, as in the case of somatic genome editing. Whatever standards are developed for somatic application, there will be less tolerance for off-targets in germline approaches, and the intended genome edits themselves might have unintended consequences, even in the absence of off-target effects. In the case of heritable genome editing, to convert a well-understood disease-causing variant gene to a widely occurring non-pathological variant, editing change could be a version of the gene that is known that not to have deleterious consequences. So, and then there are problems with the long-term follow-up. What happens if gene editing is normalized? What would happen in the long term? Carefully monitored clinical trial protocols would be required for heritable genome editing, with attention to monitoring off-target events, as well as the efficiency and correctness of the specific edit. Heritable genome editing trials would likely require long-term prospective follow-up studies across subsequent generations. Even those who have volunteered to be research subjects cannot be compelled to participate in long-term follow-up. Then coming to the next question, which of the following is not in the 7 principles for the governance of human genome editing? Is it A, promoting well-being, B, transnational cooperation, C, respect for persons, or D, the Dickey-Vicker Amendment? So I'll give you a couple of minutes to think on this and then we'll discuss the answer. Okay, so which of the following is not in the 7 principles of governance of human genome editing? It is actually the Dickey-Beaker amendment, which talks about germline genome editing, and it talks about creation and even killing of unintended embryos. That is unethical. That's what it is all about. Now coming to the 7 principles for the governance of human genome editing. So the first being promoting well-being. The principle of promoting well-being supports providing benefit and preventing harm to those affected, often referred to in the bioethics literature as the principles of beneficence and non-maleficence. Transparency. The principle of transparency requires openness and sharing of information in ways that are accessible and understandable to the stakeholders. Due care. The principle of due care for patients enrolled in research studies or receiving clinical care requires proceeding carefully and deliberately, and only when supported by sufficient and robust evidence. Responsible science. The principle of responsible science underpins adherence to the highest standards of research from bench to bedside in accordance with international and professional norms. So respect for persons. The principle of respect for persons require recognition of the personal dignity of all individuals, acknowledgement of the centrality of personal choice, and respect for individual decisions. All people have equal moral value, regardless of their genetic qualities. Fairness, the principle of fairness requires that like cases to be treated alike and that risks and benefits be equally distributed. So that's actually distributed justice and transnational cooperation. The principle of transnational cooperation supports a commitment to collaborative approaches to research and governance while respecting different cultural contexts. Let's come to question number 5. The main technical problems with safety implications for potential germline genome editing in human embryos revealed therein include the following option except one, which is A, fairness. The principle of fairness requires that like cases to be treated alike and that risks and benefits be equitably distributed, that is distributive justice. Mosaicism, a situation where not all cells of an embryo or organisms have the same DNA, in this case, the desired DNA modification. Off-target effects, where unintended changes in the genome outside of the targeted sequence occur, or on-target undesirous modifications introduced within or next to the targeted locus. So I'll give you a couple of minutes to think on this, and then we will discuss the answer. Okay, so the main technical problems with the safety implication for potential germline genome editing in human embryos revealed that therein they include the following options except one. So fairness, the principle of fairness, we already discussed. It's not a part of germline genome editing. So it's actually the 7 principles of genome editing. Mosaicism is possible. Off-target effects we have discussed, it's possible. And the on-target undesired effects are also possible. So what are these safety issues in germline gene editing? So the main technical problems with safety implications for potential clinical germline genome editing in human embryos involves mosaicism, a situation where not all cells of an embryo or organism have the same DNA. In this case, the desired DNA modification. It could cause off-target effects where unintended changes in the genome outside of the targeted sequence occur, or on-target undesired modification introduced within or next to the targeted box would also happen. So let's come to question number 6. As per a December 2018 poll, Americans draw the line at the so-called enhancement, but favor the use of genetic engineering to address disease and A, disability, B, clinical research ethics, C, cancer, or D, oocyte procurement. I'll give you a couple of minutes to think on this and then we discuss this. As per a December 2018 poll, Americans draw the line at the so-called enhancement, but favor the use of engineering to address disease and disability. So let's talk about it, about which gene or disease to target. As per a December 2018 poll, Americans draw the line at so-called enhancement, but favor the use of genetic engineering to address disease and disability. Which diseases and disabilities to target, however, is still an open discussion. Some questions that may help us inform that decision would be, should there be a focus on infectious disease resistance, only fatal conditions? Will we decide that there is a need to quantify the degree of suffering? If an effective treatment already exists, should we still seek prevention through genetic modification? Is childhood versus adulthood onset of illness an important factor? Not all sequence variants are guaranteed to cause diseases. Example, in case of the BRCA genes, which called breast cancer, should they be considered? What about orphan diseases? And should certain types of disabilities be prioritized over the others? So these are some of the questions which would help us answer this question, this ethical dilemma. So coming to question number 7, he, Jan Kui, shocked the world when he broke the news that his team at Southern University of Science and Technology in Shenzhen, China, has successfully edited embryos using CRISPR-Cas9 and delivered two baby girls on a January 25, 2018, November 15th, 2018, November 25th, 2018, or it's a December 25th, 2018. I'll give you a couple of minutes to think on this, then we'll discuss the answer. Okay, he, Jan Kui, shocked the world when he broke the news that his team at Southern University of Science and Technology in Shenzhen China has successfully edited embryos using the CRISPR-Cas9 technology and delivered two baby girls on November 25th, 2018. And let's see about this in detail. So although genome editing is a common procedure, the ethical issues of editing are not just tied to the procedure, but also to the use that it is made of it. The National Academy of Sciences and National Academy of Medicine, in conjunction with the Royal Academy of Sciences and Chinese Academy of Sciences, have constituted a committee on human gene editing, scientific, medical, and ethical considerations, chaired by Professors Alta Chero and Richard Hines, to perform in-depth study of the issue, during which inputs and guidance from multiple stakeholders from and around the world will be solicited before issuing a consensus study report. So let's see the case of E. Jankuri in specific. So this is a very important case in human gene editing and the ethical dilemma that surrounds it. So on November 25th, 2018, that's the date, E. Jankuri shocked the world when he broke the news that his team at Southern University of Science and Technology in Shenzhen, China, has successfully edited embryos using CRISPR-Cas9 technology and has delivered two baby girls. Participating as a speaker at a genome summit in Hong Kong, He Jiankui declared that he was proud of altering the genes of twin girls so they could not contract HIV. Now, the problem with this, we have already talked about how HIV infects a person and its transmissibility that is involved by the CCR5 receptors and the CD4 receptors. Those things are involved for T cells. So he made the necessary modifications so that the girls could not contract the disease. While that is definitely a very it's a good step forward, but there were ethical considerations, whereas how to test this efficacy of this mutation. So to do that, one would have to expose the girls to HIV, which is again unethical. So something like that it came up, and what followed was scientists all around the globe, they condemned his action, raising concern that gene editing technology was too premature to be used for reproductive purposes. Due to immense international pressure and in line with China's domestic laws, he and his associates were convicted of violating a government ban by carrying out his own experiments on the human embryos. The court declared that they acted in the pursuit of personal fame and gain and had seriously disrupted medical order. He Jiankui was jailed for 3 years and fined 3 million yuan or 430,000 US dollars or 328,000 euros. The court also handed lower sentences to the two men, Zhang Renli and Qin Xinzu, for conspiring with he carry out the experiments. So China anyway has a very low threshold for these kind of ethical considerations, because we have a lot of reports from China where they perform these kind of futuristic experiments even on human subjects. So China often crosses the line. So let's see what are the laws that are already present in China. So in 1993, the Chinese Ministry of Public Health releases an outline of quality controls for clinical studies of human somatic and gene therapy. In 1999, guiding principles for human gene therapy trials were finalized. In 2001, regulations on administration of agriculturally genetically modified organisms safety published, which heavily regulates the import and domestic production of genetically modified crops. In 2003, China's Science Ministry bans the implantation of genetically modified embryos for reproductive purposes and prohibits altered embryos developing past 14 days. No punishments are attached to the regulation. 2003, Ministry of Health and Ministry of Science and Technology jointly developed the ethical principles of research of human embryonic stem cells, which state that embryos derived by genetic modifications must not be allowed to develop for more than 14 days, and that once they have been used for research, they cannot be implanted into humans or other species. So 2003 again, Chinese State Food and Drug Administration or the National Medical Products Administration publishes guidance for human gene therapy research and its products, which outlines requirements for applications of gene therapy in a clinical study. The document also outlines requirements for quality controls and product efficacy and safety tests. In 2007, the Ministry of Health releases measures for ethical review on biomedical research involving humans. In 2015, Chinese researchers first to edit the gene using CRISPR in a human embryo. A gene associated with a fatal blood disorder was modified, but the embryos were not implanted. The editing was not successful in most embryos in the experiment. In 2019, Li Jiankui, who altered the DNA of human embryos that were carried to term, is censured by the Guangdong Health Ministry and fired from the Southern University of Science and Technology. In 2020, the adoption of a new civil code in China, which includes personal protections from human genes and stricter regulations for human gene editing were imposed. Question 8 and the final question. The dash is one of the 30 genetically modified organisms to sidestep the USDA regulatory system in the past 5 years? Is it A, banana, B, BT cotton, C, BT brinjal, or D, mushroom? So I will give you a couple of minutes to think about it and then we'll discuss the answer. So the mushroom is one of the 30 genetically modified organisms to sidestep the USDA regulation in the past 5 years. Let's talk about it. So regarding the genome engineered plants, there are some regulations. Some countries regulate the process while other regulates the characteristics of the final product. While some countries have established biosafety regulations for genome edited plants or declared their deregulation, most countries have yet not established their position. Challenges in regulating plant genome editing includes market access and addressing societal concerns about its biological safety without limiting the development of the technology. Transgene-free genome-edited plants are similar to varieties containing genetic variations created naturally. Therefore, commercialization of genome-edited plants, or their products might bypass the strict biosafety regulations required for transgenic plants. So there are certain countries and their, you know, um, their situation. So like Argentina has regulated genetically modified plants and a case by case, mostly non-regulated situation for genome edited plants. So genetically modified plants is like we have transgenes, and genome edited plants are used to enhance certain characteristics of a plant and certain these situations like that. So these vary across various countries. For example, in case of India, genetically modified plants and genome edited plants both are regulated, while a lot of countries, even developed countries, where genetically modified plants are regulated, but genome edited plants are not regulated. So certain things that happens in Japan. And even in case of India, there have been trials of the golden rice also. I think somewhere in the northeast, and professors from IIT Guwahati are involved. So things like that, they are in their stages of infancy in India at least. So we talk about US. The United States Department of Agriculture declared in March 2018 that genome editing is equivalent of conventional breeding in some instances and therefore does not require regulatory oversight within the American regulatory framework. A mushroom engineered to resist browning and a waxy corn engineered to contain starch composed exclusively of amylopectin are the first CRISPR edited crops to be approved for commercialization in the USA with no regulation. The decision not to regulate was based on the fact that no foreign DNA transgene was inserted during editing and that the resulting change did not involve resistance to pesticides or herbicides. So let's look at the questions once again if somebody has missed it. So coming to the first question, so that was the term bioethics has been coined by Fritz Jor, a Protestant pastor, philosopher, and educator in Hale and the Sale in the year 1926. Then comes question 2. The Asilomar Conference was a milestone for science because it was the result of self-regulation proposed by the scientists. Then we have question 3. In case of heritable genome editing, there are two distinct concerns, one being the possibility of off-target editing and the other being the intended genome edits themselves might have unintended consequences, even in the absence of off targets. So the question number 4 was which of the following is not in the 7 principles for the governance of human genome editing? That is Dickey-Wicker amendment. Question number 5. The main technical problems with safety implications for potential clinical germline genome editing in human embryos revealed therein include the following options, except fairness. The principle of fairness is actually included in the 7 principles for genome editing, but not in germline editing. So in question number 6, as per a 2018 December poll, Americans draw the line at the so-called enhancement, but favor the use of genetic engineering to address disease and disability. Question 7. He shocked the world when he broke the news that his team at Southern University of Science and Technology in Shenzhen, China, has successfully edited embryos using CRISPR-Cas9 and delivered 2 baby girls on November 25th, 2018. And that involved their resistance to getting an HIV infection. And the final question, the mushroom is one of the 30 genetically modified organisms to sidestep the US Department of Agriculture regulatory system in the past 5 years. So with that, I would like to thank you for joining. The problem solving sessions, live problem solving sessions. This was the last session, and I would like to wish you all a very good luck for your exams and all the very best. Thank you very much for joining in. And if nobody has any doubts, we can call this as a session and end it right here.